Lecture 4, Aggregate Planning, Part 2. In the previous Part 1, we had an introduction to aggregate planning, and now in this part, we are going to have the definitions and assumptions that we need to consider for aggregate planning. So in aggregate planning, we assume that we are going to plan for the T periods ahead. So the planning horizon will include T periods, okay? And here we assume that we have forecasted the demand over the T periods. So we have the D1, D2 up to DT, the demands in the future planning horizon, okay? And now in the aggregate planning, we are going to obtain the WT as the workforce levels at each period and also production levels, PT. So we show the workforce levels with WT and production levels with PT. And the goal here is to minimize the total costs over the T period planning horizon. Okay, so yeah, our objective is minimizing the total costs here, and the solution, the solution that we want to obtain here is the level of workforce and the level of production over the next T periods. Okay. So in the aggregate plan, since we are going to combine different types of products in a product line, so the individuals may be in different shapes or different types and so on, but we are going to combine them in a group as a product line and then prepare the plan for that product line. So here we need to define an aggregate unit in order to combine all those individual items. So the aggregate unit could be defined based on actual units or weight, for example, tons of steel, or it could be defined based on volume, for example, gallons of gasoline, or it could be defined based on the time or maybe dollars of sales. Okay, for example, here let's assume a beer company which producing non-alcoholic, light, regular, and strong types of beer in draft, can, and bottle. Okay, so as you see here, we have different individuals: draft, can, bottle, non-alcoholic, light, regular, strong. Okay, but the unit that is common in all these types of individual is liters. So here the aggregate unit will be liter. Okay. Hierarchical production planning, HPP. In any hierarchical production planning, we have the three levels for the planning. The first, or the lower level is the items. The items are the final products to be delivered to the customer, and usually we refer them as SKU or stock keeping unit. Okay, and if we group the similar items in a family of items, then we will shape the families. So the families will be a group of items that share a common manufacturing setup cost actually, and then we may are able to group the families as well in the types. Okay, so yeah, groups of families with production quantities that are determined by a single aggregate production plan. So yeah, here in aggregate planning, we may prepare our plan for the types or for the families, but not for the items. Yeah, that will be very low level planning and it's not considered in the aggregate planning. So yeah, the aggregate planning could be conducted for the types or families. Okay. So let's see what are the important issues in the aggregate planning. A smooth thing actually refers to the costs and disruptions that are result from making changes from one period to the next. If there is no change from one period to the next period, then there is no cost. But if there are changes, then we have a smoothing cost here. Okay. So, for example, hiring new employees or firing the employees or increasing the production level, these are the changes, right? And so because of that, we will have a smoothing cost. The second issue here is the bottleneck planning. So here, because of the capacity restrictions, and if we have a period with peak demand, I mean demand is not uniform over the period, so we have one period that has the highest demand during the planning horizon, so that period will be that demand will be the peak demand, right? And because of the capacity restrictions, then that period will be our bottleneck. Okay, so we'll see how we can deal with this issue in the aggregate planning. Planning horizon, here we are assuming T as the length of the planning horizon, but the question actually here is what's the right value? Yeah, or what's the impact of I mean the effects of one horizon to the next. I mean rolling horizon and end of horizon effect. So yeah, in the horizon at the end we may not able to clear the stock, so we'll have the end inventory, so it will impact the next horizon, right? And the fourth issue here is the treatment of demand. So in the aggregate planning, we're not going to consider the uncertain demand. So here we are going to assume demand is known. So yeah, we ignore uncertainty, and then we will focus on the predictable or systematic variations in demand, such as seasonality. Okay. So let's see what are the relevant costs here in aggregate planning. The first one is a smoothing cost. As we discussed in the previous slide, anytime that we have changes from one period to the next, then we will have the smoothing cost here. So yeah, any change in workforce or production level will cause the smoothing cost here. So for change in workforce, if you are going to hire or lay off some employees, then for hiring, for example, hiring new workers, these are the related costs. Advertising positions, interviewing candidates, and also training new hires. So yeah, these are the costs of this change. Or in case of firing, we need to pay the severance pays to the fired employees, right? So this is the smoothing cost here for this change. So in the real world, the cost of increasing the workforce and decreasing the workforce, or increasing the production level and decreasing the production level, is not symmetric. It's asymmetric and non-linear. Okay, so yeah, the cost of increasing the production rate is different than the cost of decreasing it, and also the marginal costs may increase with the magnitude of the changes, so it's not linear. But here in this course, we are going to assume a linear function. So this is our assumption for simplicity. So yeah, we'll consider a linear function, but we will consider different slope actually for hiring and firing. So in the next slide, we'll see a typical cost function here for changes in workforce size. Okay. So as see here, we are assuming linear functions, so the slope is not changing over the magnitude of the change. The slope is constant, but as you see here, the slope of hiring CH is different than the slope of the firing CF. Okay. The holding and shortage costs definition is exactly the same as before. So if we are going to hold some items from one period to the next, then there will be holding costs. Or if we have a shortage in a period and then we are going to satisfy this shortage demand in the future, then there will be shortage cost. Okay. Regular time costs. So any costs regarding the production on regular working hours is called regular time costs. Like the actual payroll costs of regular employees working on regular time, the direct and indirect costs of materials, right? And other manufacturing expenses like overheads and employee benefits. So as you see here, it doesn't matter if we are producing or we are not producing, we need to pay all the regular time costs. So the regular payroll costs actually are called sunk costs. So yeah, I mean, if there is no overtime working in a company, or if there is no idle time, then yeah, we need to pay this sunk cost. And if in that case, if we are going to compare different strategies, assuming that there is no overtime or there is no idle time, then we can ignore the regular time cost because it will be exactly the same between all the strategies, right? But in the case that we have overtime maybe in one strategy, then in that case we can consider these costs. Okay. Overtime and subcontracting costs. So if you have bottlenecks and we're not able to produce the required items in regular time, then we may consider the overtime working, or maybe subcontracting subcontract type of the production. So here, when we are going to use the overtime working, then the cost per unit rise sharply. So here, yeah, usually the rates, I mean, the cost in the overtime is higher than the regular time, and also the efficiency is lower. Okay. And also for some subcontracting actually is the case that we ask some outside supplier to produce the items for us. So again, in this case, the cost will be higher, normally will be higher than ours. So here the costs are usually higher, and also here we assume that they are linear as well in terms of the volume. Okay. And other costs here are idle time, cost, and etc. Okay. The competing objectives. So let's see what are the competing objectives here. The first one is to react quickly to anticipated changes in demand. So in this case, this is an extreme case, and here we are saying that we are going to react quickly as much as possible for anticipated changes in demand. So this will require making frequent and potentially large changes in the size of the workforce. So we don't know, it may be cost effective, but it may be not. So the second, let's say, other extreme case here is to adopt the objective of retaining a stable workforce. So here we're not going to quickly respond to the anticipated changes in demand. So we're going to keep our level of workforce the same over the time. So this usually results in large build-ups of inventory during the period of low demand. Yes, since we are not going to fire our employees, we are going to work during the time that we have low demand, then in that time we will have higher inventories in our warehouse. Okay, but the third one, I mean, could be something between these two, right? Yeah, to develop a plan that maximizes profit subject to constraints on resources. Okay. So based on the competing objectives defined in the previous slide, we have three strategies here for aggregate planning. The first one is a level strategy. So in the level strategy, we are going to keep a constant level of production and also employees over the time. So we're not going to change our employees, I mean the number of employees and the production level over time. So here actually the workforce adjustment will be low, but we may have excessive inventory in our warehouse, right? The second one is chase strategy. In the chase strategy, we are going to quickly respond and react to the changes in the demand. So here we are going to change the production rate and workforce level in order to match with the forecasted demand over the time. So this is exactly on the opposite side of the level strategy. So here we will have low inventory, but we may have excessive workforce adjustment. Okay, and the mixed strategy here is something between these two extremes. So yeah, I mean anything between these two extremes will be considered as a mixed strategy here. So in this figure, we're having the two strategies. So as you see here, this is the level strategy. So we have a constant level of production. So here, as you see here, let me show with a different color here. Yeah, as you see here, the actual demand is lower the production level, right? So in this period, we will have inventory. So, and again here, the actual demand is higher than the production level, but since we have inventory, we will satisfy those demands from those excess demand from the inventory, right? So yeah, we have a fixed level of production here, and it's a level strategy. But in this case, the chase strategy, we are going to change the production level to match with the changes in the demand. So yeah, here, as you see here, we'll have lower and lower inventory, but we'll have maybe more adjustments in the workforce and production level. So we'll see in the next part that what are the impact of these two strategies in terms of the total cost for the company, and then we'll see how can we optimize our production level in order to minimize the total cost of the firm. Okay, thank you.